Hello, so I will demonstrate you Exfo's optical spectrum analyzer. I've got my OSA connected into the monitor port of an actual DWDM system, which has some 10 gig channels, 100 gig and 200 gig channels. So the easiest way to see what type of channels you're dealing with is to use the button Discover. So I hit the button Discover, and the OSA will automatically scan all the spectral range and show me the different wavelengths I've got present. So here I see I have 7 channels. This, for instance, is a 200 gig channel. This is 100 gig. And these, the channel 1, 3, 4, and 5 are all 10 gig channels. So the trace is really power in dBm as a function of wavelength in nanometer. At the bottom, I've got all my channels, central wavelength of each channel, power. OSNR value, we have to be careful because there's different types of channels, so we might have to use in-band OSNR or Pulmux OSNR. So in this case, the noise level that we see here based on the OSNR method is not the right one. One thing I noticed though on this initial scan is that one of the channels has not been properly defined. So now what I can do is, given I know I'm working on a 50 gigahertz grid, I can come here and put a 50 gigahertz channel width in my analysis setup. I do OK, and then I push start, and I can make a new measurement. So I see all my channels are properly defined. Channel 1, 2, 3, 4, etc. Some of the interesting features of the OSA is the flexibility in terms of displaying the graph. So I can, for instance, select the rectangle and I can zoom on a specific channel, like channel 1, like this, for instance. I can also take the hand and move on my spectrum to see my different channels. I can come back to full mode, like this. Then if I come back here, I get access to my results. I have also access to what are called markers. So markers allow me, if I go precisely, they allow me to measure specific levels. So if I'm interested in knowing, for instance, the distance between channel 1 and channel 2 in terms of nanometers, I can position my 2 markers like this. Wavelength, channel marker A 1542.8 nanometers, marker B 1547.7 nanometers, delta BA in wavelength, that's 4.9 nanometers, or in power I've got 16 dB of difference between the two, so the point taken here and this one. So that's the markers. Okay. There are also different types of OSNR measurement we can make. So we have the option here in the acquisition setting. So I have the in-band and the in-band. These two methods would be appropriate for 10 gig channels with networks containing ROADMs, or 40 gig non-coherent channels. So performing an in-band measurement is very simple. I just select in-band, which is our newer generation, and I just hit start and wait for the OSA to perform the 500 scans. Okay, so now the in-band OSNR measurement is completed. So for all the channels that are not polarization multiplex, so that is the 10 gig channels in this particular system, I see that I have, in terms of noise type I and B. The question marks tell me that these channels, the in-band OSNR analysis couldn't be made, and this is normal because these are 100 gig channel or 200 gig. So channel 2, 6, and 7 will have to use another method. But for channels 1, 3, 4, 5, the in-band OSNR method has been applied successfully, and I get OSNR values around 27 dBs. So now I have my trace with all the 7 channels on for the commissioning assistant. I will save that trace. I save it on the desktop. I will call it that trace all on. I save it. Oh, that's it. So now we've just turned off channel 6, so we see that now we had the channel on. Now if I do another scan, we'll see that channel 6 is turned off. So now what I'm doing is I'm doing an acquisition in-band 100 scans of the system with a channel 6 turned off. So now I have my trace for the commissioning assistant. Channel 6 is turned off, 100 scans. So I will save it. I will bring up the keyboard, call it channel 6 off, and I save it. So now channel 2, which is 100 gig, has been turned off. So now you'll make the acquisition for 100 scans of the whole trace, including channel 2 turned off. Now I have the trace with channel 2 turned off for the commissioning assistant. So I will save that trace again. I bring up the keyboard here. So we'll call it channel 2 off. I save it. And now I can perform the commissioning assistant measurement. So I go in assistant. I choose commissioning. First step, some instructions. Second step, select the trace with all channels turned on. I can load a measurement file. In this case, I will go and select my trace all on. Then I go in off channel traces. Here I can select all applicable traces with one channel turned off. I add my channel 2 off. And I add my channel 6 off. Last step, channel matching review. So the OSA is associated to channel 2 and channel 6, the two traces with the channels off. I can decide the type of analysis I want, either the CCSA, the standard from China, or the IEC standard. I will choose the IEC standard, the newer one, and I hit OK. And then I get my OSNR results here for channel 2 and channel 6 based on the IEC standard.